Assalamu alaikum. Welcome to this MATLAB tutorial. Today I am going to teach you how to solve symmetrical fault or three-phase fault analysis using the MATLAB programming. For this purpose, I have taken the examples from the book Power System Analysis by Hadi Sadat, Chapter 9, Examples 9.1 to 9.6. Consider the example which consists of 3-bus power system having generators at bus 1 and 2. The per unit impedances of the generators and transmission lines are given as shown in the figure. We have to find the fault current, the bus voltages and the line currents during the fault when a balanced 3-phase fault with a fault impedance of 0.16 per unit occurs on bus 3, bus 2 and bus 1. Now look at this figure which shows the simplified one-line diagram of the example. Friends, the mathematical solution of this example can be found in the Hadi Sadat book. For your convenience, I have uploaded the example solution in the form of PDF link in the description section. You can download it from there. Now I am going to perform the symmetrical fault analysis in MATLAB. However, before going to start, I want to highlight again that for the solution of symmetrical fault analysis, Hadi Sadat has already made the built-in functions. Therefore, for the convenience, you must have the MATLAB folders of the Hadi Sadat book. On this topic, I have already made the video on how to save MATLAB folders of Power System Analysis book by Hadi Sadat in MATLAB using the set path feature. I would strongly recommend to watch this video first for the better understanding of this topic. It is because we will directly call the MATLAB functions from the MATLAB folder of the Hadi Sadat book. Let's start. At the first stage, we need to open the Hadi Sadat MATLAB folder in the current folder section. As you may see, the example is already written in the MATLAB programming by Hadi Sadat. Therefore, just double click on it to open this program. Now I am going to explain how this program is written. Look at the format of the MATLAB program. It may be noted that Z data matrix consists of impedance data of the generators and transmission lines and contains the 4 columns. The first 2 columns are the line bus numbers and the remaining columns contain the line resistance and reactance in per unit. Now we are going to put the values from the example data. For this purpose, just look at the figure. It can be observed that the generator is connected at bus 1 having the reactance of 0.2 per unit. It means that this generator is connected from bus 0 to bus 1. Therefore, in the MATLAB program, you can see in the first column 0 is written and in the second column 1 is written. In the third column 0 is written because resistance is not given in the data. Whereas in the last column reactance of 0.8 is written to represent the reactance of the generator. Similarly, look at the figure again. It may be noted that generator 2 is connected at bus 2 having the reactance of 0.4 per unit. It means that this generator is also connected from bus 0 to bus 2. Therefore, in the MATLAB program, you can see in the first column 0 is written and in the second column 2 is written. In the third column 0 is written because resistance is not given in the data, whereas in the last column reactance of 0.4 is written to represent the reactance of the generator. Similarly, look at the figure again. Now the line impedance from bus 1 to bus 2 has the reactance of 0.8 per unit. Therefore, in the MATLAB program, you can see 1 and 2 are written in the first and second column. In the third column 0 is written because resistance is not given, whereas in the last column reactance of 0.8 is written to represent the line reactance from bus 1 to bus 2. Friends, in order to save the time, it is not necessary to show you the line data of each transmission line because it is very easy process. You may repeat the same procedure to put the values of all transmission lines. Now in order to perform the symmetrical fault analysis, the first requirement is to obtain the bus impedance matrix. Therefore, to obtain the bus impedance matrix, this program has used built-in function namely zbuild to calculate its bus impedance matrix. Let me show you the built-in function of zbuild here. Just double click on it to open it. This shows the zbuild MATLAB function program. Now the next step is to calculate the fault current, voltages and line currents when three-phase fault occurs. For this purpose, this program has used another built-in function namely SimFault. It may be noted that SimFault function uses the impedance data and bus impedance matrix as the input. Let me show you the built-in function of SimFault here. Just double click on it to open it. This shows the SimFault MATLAB function program. At this stage, our program is complete. This program has the beauty that this program can be used as it is for any kind of power system problem. Only we have to change the Z data in the program according to the example data. Now let's run the program by clicking on this button. Click on Change Folder. You can see MATLAB has first calculated the bus impedance matrix for the given example data. Now compare the answer with the answer obtained in the example. You can see both answers are correct. Furthermore, you can see that MATLAB program asks you about the bus at which fault occurs. In our case, the three-phase fault occurs on bus 3 as shown in the example data. Therefore, write here 3 and press enter. Now it asks about the fault impedance in complex form. Furthermore, it is also written that for voltage fault enter 0. Now you may be confused that what does it mean. Actually, voltage fault means short circuit occur at the terminals of the generators. Or this voltage fault is also known as solid ground fault. In solid ground fault, impedance is normally 0. Therefore, if in any example data fault impedance is not given or it is a solid ground fault, then we will write fault impedance as 0. However, in our example, the fault impedance is J0.16 per unit as given in the example data. Therefore, write here J multiply with 0.16 and press enter. You can see MATLAB has calculated the fault current, bus voltages and line current for the given example data. Now compare the fault current answer with the answer obtained in the example. You can see both answers are correct. Similarly, compare the bus voltages answer with the answer obtained in the example. You can see all answers are correct. Friends, it may be noted that according to theory, the voltage at faulted bus must be 0. However, in this example, it can be observed that voltage of the faulted bus V3 is not 0, but it has the magnitude of 0.3 per unit. It might create confusion. May I ask from you that what is the reason for this magnitude? What do you think? Is it correct or not? The answer to this confusion is that it is correct. Because in this example, fault impedance or ground impedance is given as 0.16 per unit. Therefore, there exists some voltage drop due to ground impedance. However, if ground impedance is 0, then the voltage at bus 3 will also be 0. I think it is better to prove this statement here in this example. To do this, we have to run the program again. You can see in the end, it asks whether to continue this program for another fault or not. Suppose we want to close it, then it says write n. Therefore, write n in the parenthesis and press enter. Now run the program again by pressing this play button. Now write fault impedance 0 and press enter. You can see now voltage of the faulted bus 3 is 0. Compare the answer with the answer obtained in the example. You can see both answers are correct. Hence, it is proved that voltage at the faulted bus will be 0 if ground impedance or fault impedance is 0. Friends, we have compared the fault current and bus voltages when fault occurs at bus 3. However, we have not compared the line currents. Therefore, to compare the line currents for this case, Let's run the program again by repeating the same procedure. Now compare the line current's answer with the answer obtained in the example. You can see all answers are correct. At this stage, our case A is complete. Now we are going to calculate the fault current when fault occurs at bus 2. To do this, you can see MATLAB program asks whether you want to continue or not. Therefore, write Y in the parentheses and press enter. You can see it asks about the faulted bus again. Write here 2 and press enter. Similarly, write here fault impedance of J multiply 0.16 and press enter. You can see MATLAB has calculated the fault current, bus voltages and line current for the given example data. Now compare the fault current answer, bus voltage answer and line current answer with the answers obtained in the example. You can see all answers are correct. At this stage, our case B is also completed. Now we are going to calculate the fault currents when fault occurs at bus 1. To do this, you can see MATLAB program asks whether you want to continue or not. Therefore, write Y in the parentheses to continue and press enter. You can see it asks about the faulted bus. Write here 1 and press enter. Similarly, write here fault impedance of J multiply 0.16 and press enter. You can see MATLAB has calculated the fault current, bus voltages and line current for the given example data. Now compare the fault current answer, bus voltages answer and the line current answer with the answer obtained in the example. You can see all answers are correct. Friends, in this video tutorial, I have discussed how to calculate the symmetrical fault or three-phase fault analysis using the MATLAB program. By using the same strategy, the symmetrical fault analysis of any power system from small to large size can be performed. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.